Our topic today is critical computing. Now in critical computing, let's look at decision support systems, DSS. It is a computer system designed to gather information from a wide range of sources, analyze it, present it in summarized or graphical formats that aids in decision making. So basically, we use software to gather information, and a good means is your spreadsheet, your database. We can get information, it can be analyzed there and can be used to make decisions. Now, a well-designed spreadsheet which models the current and future performance of a business will help make decisions related to a business. Now, before we come to the farmers, a simple example also with the decision support system is, for example, if you want to look at sales of heaters in area or versus sales of blankets. By looking at data mining, we're able to pull information from different regions and make decisions as to what sells better in a certain region and stock those items. So that will help in the profitability of a business. Now another example here is the decision support system to help farmers make their farms as productive as possible by taking into account many different factors such as climate data, soil analysis and market prices. Now, we knowing what sells well will also determine what is to be planted. So that's decisions made. In large-scale businesses, the DSS is often powered by data warehousing and data mining, which I explained to you just now. For example, looking at what sells well in shops in different areas, that is what the shops can stock and promote what is not selling well. It helps in profitability of the business. Now, the next example is expert systems or knowledge-based systems. An expert system is a limit rule-based form of artificial intelligence. It's rule-based. It's based on a rule where the expertise of human is coded into a computer system that can take input and arrive at a rule-based decision far more quickly than most humans can. Now, the other system we're using software, DDS, decision support systems. There we work with software that gives information and users can make decisions. But with expert systems, it is based on knowledge systems. So there is knowledge that you receive and then make decisions based on that knowledge. The computer is programmed. The key word here is the computer is programmed to make decisions. So here, rule-based systems again can easily be programmed because there are a fixed number of possible outcomes or answers for each question. Expert systems are no longer explicitly called expert systems, but rather knowledge-based systems, and they incorporate additional AI, artificial intelligence, such as fuzzy logic. Fuzzy logic deals with reasoning that works with probabilities. For example, if it is overcast and humid, there are chances of rain. Think about fuzzy logic in washing machines. Washing machines that have fuzzy logic, the amount of water that's released is based on the load capacity and the weight. So that's fuzzy logic. If the load is a certain amount of kilos, then that's certain amount of water needs to be released. Your next one is an overall of expert system. Then remember, the expert system has the knowledge base, therefore it's also called knowledge base system. It has a knowledge base and it has a decision engine. Now the knowledge base are all the facts and rules, for example, symptoms of diseases, and the decision is a logic that accepts the data and deduces the output. It looks up the knowledge base and then deduces new facts or rules to generate a decision output. Expert systems examples are your medical diagnosis systems, automatic pilot systems, and agricultural crop management. These are your examples. Now, the distributed computing, another concept under critical computing. This is where by the resources of different computers are shared and used at the same time to solve a single problem. Now, all processing is not always possible with one computer system, so many computers can be used throughout a network or different networks to solve a problem. It can even include an individual's home computer. The problem is broken into components that the different computers can work on, and the computers communicate with each other to let each other know when a segment is complete and when new segments are required. Now, many computers are idle and not in use, so distributed computing will allow those computers' resources to be used effectively, like even including your home resource. Applications for distributed computing is like genetic research, weather modeling, oil exploration, physics research, circuit design, financial modeling, and web searching. And think about web searching. When you are searching for contents on a website, one computer is not used to find the different web pages relating to what you are searching. So you have to use many computers, so it's distributed computing involved. Specific examples, one is SETI at home. If you go to this website, you will see this project allows thousands of people to share the processing power of their personal computers in the search for signals from outer space. So if you want to get involved, when the computer is on, connected to the internet and idle, it fetches data from SETI at home site, processes it, and sends results back. There are also many other examples of distributed computing. One is climate prediction, and then we have folding at home, which is researching of folding of proteins for medical or drug development purposes. Advantages of distributed processing or computing. It offers a cost-effective solution and ability to use many resources. So many idle resources can be used. It's cheaper than having one machine to do all the work. So you can use the CPU power and the RAM of many computers. It provides a method to solve problems that need enormous amounts of processing power. That's not capable of to be done by one computer. It saves both money and resources by utilizing the power of idle computers. That is the section on critical computing. Please complete the activity.